I'd like us to be aware that the directions in orthogonal components are not necessarily always expressed in terms of angles. They may be also expressed in terms of ratios. If you remember, SOHCAHTOA is always associated with right triangles, and right triangles are what you always create when you're dealing with orthogonal components. So let's take a look at this first right triangle where the vertical leg is 3 meters and the horizontal leg is 4 meters. Let's say I'm interested in this angle, which I will call theta. Well, let's take a look at the given information. The leg that is opposite to the angle, that is a given info, which is 3 meters, and the leg that is adjacent to the angle theta is also given, which is 4 meters. So you have the leg that is opposite to the angle that you're interested in, and you also know the leg that is adjacent to that angle, therefore you must use the tangent definition. By definition, tangent theta is equal to opposite over adjacent. Opposite is 3 meters, adjacent is 4 meters. Therefore, if you are interested in what theta is, all you have to do is find the arctangent of 3 over 4, and you plug that in your calculator. Theta is equal to 36.87 degrees. Well, let's take a look at the two other definitions in SOHCAHTOA. Sine theta, where theta was just found to be equal to 36.87 degrees. And by definition, sine is opposite over hypotenuse. The angle that you are using is 36.87. Opposite of that angle is 3 meters. And the hypotenuse of the right triangle can be easily found by Pythagorean theorem, which is the square root of 3 squared plus 4 squared. And that's equal to 5 meters. So again, by definition, sine is opposite over hypotenuse. Hypotenuse is 5 meters. Am I saying that sine of 36.87 degrees is numerically equal to 3/5? Yes. When you plug in sine 36.87 degrees in your calculator, that is equal to 0.6. And 3/5 is indeed also equal to 0.6. So they are numerically equal to each other. How about cosine? Cosine theta, where again theta is 36.87 degrees. By definition, cosine is adjacent over hypotenuse. The angle that you are using is 36.87. Adjacent to that angle is 4 meters. The hypotenuse of the right triangle is 5 meters. So therefore, am I again saying that cosine 36.87 degrees is numerically equal to 4/5? That's correct. That's exactly what I'm saying. If you plug in cosine 36.87 degrees, that's equal to 0.8. And indeed, 4/5 is also equal to 0.8. So they are indeed equal to each other. So where am I going with this? Let's say I have a vector and the magnitude of that vector is 100 kilonewton. I am interested in finding the x component as well as the y component of this vector. Isn't the x component just this component, which I will call 100 subscript x? Isn't the y component just that vector, which I will call 100 subscript y? If you look at the x component and you look at the angle that you already know, which is 36.87 degrees, you know the hypotenuse, which is 100. So you're looking for the side that is adjacent to the angle. You already know what the hypotenuse is, therefore you should use the cosine definition. And let's write this down. Cosine of 36.87 degrees is by definition adjacent over hypotenuse. Adjacent, we call that 100 subscript x. The hypotenuse is the vector 100 kilonewton. So therefore, if you are interested in the component of the vector in the x direction, don't you just multiply 100 times cosine of 36.87? And since it is to the left, you must put a negative sign in front of that term. Or it is equal to 100 times the ratio that is numerically equal to cosine 36.87. That's just 4/5. And again, you must put a negative sign in front of that term. If you're interested in what that is equal to, that's equal to negative 80 kilonewton. How about the y component? 100 subscript y. 100 subscript y. The y component is equivalent to this component. Well, this component is just opposite of 36.87. Opposite, and I know the hypotenuse already. So I am looking for the opposite component of the angle theta. I know the hypotenuse, therefore I must use sine. Let's write this down. Sine of 36.87 is equal to the component that is opposite of the angle, which we called 100 subscript y, over the hypotenuse is 100. So therefore, if we're interested in the y component, don't I just multiply 100 times sine of 36.87? And if you're interested in using the ratio that is numerically equal to sine 36.87, you would just have to multiply 100 times 3/5. And this is equal to 60 kilonewton. You don't have to memorize anything or commit to memory anything. All you have to know is the definition of sine and cosine and tangent. And let's look at this again. The x component of the 100 kilonewton vector, the x component is the component that is adjacent to 36.87. Since I already know what the hypotenuse is, all I have to do is use the cosine definition. And by definition, cosine is adjacent over hypotenuse. The y component of the vector is just equivalent to this component, which is opposite of that angle. And since I already know the hypotenuse, that's why I used the sine function. And by definition, sine is opposite over hypotenuse. Why don't we try the second example and see what you think? I have a vector, and the magnitude of that vector is 50 pounds. If I measure from tip to tail to that vector, that is equal to 6.083 inches. If I draw a right triangle, the vertical leg is equal to 1 inch. Let's define this angle alpha. Alpha, let's look at the information that we know and let's see if we can find alpha. The leg that is opposite of the angle that we're interested in is given, which is 1 inch. The hypotenuse of the right triangle is given, which is 6.083 inches. So therefore we must use the sine definition. We know the leg that is opposite to alpha. We know the hypotenuse of the right triangle, therefore we must use sine. Let's write it down here. So sine of alpha, by definition, is opposite over hypotenuse. Opposite is 1 inch. The hypotenuse is 6.083 inches. Therefore, if we're interested in what alpha is, all I have to do is find arc sine of 1 over 6.083 inches. And when you plug in your calculator, that is equal to 9.46 degrees. Well, let's find the x component and the y component of 50 pounds. The x component is this component right here. That is adjacent to alpha. I already know what the hypotenuse is, which is 50 pounds. So therefore, 50 subscript x, the x component of 50, is just equal to 50, the hypotenuse, times cosine of alpha, which is 9.46. Well, if you're interested in using the ratio that is numerically equal to cosine of 9.46, what would that be? By definition, cosine is adjacent over hypotenuse. Adjacent, the leg that is adjacent to alpha, we don't know that yet, but certainly we can find this using Pythagorean theorem. The hypotenuse is 6.083 inches, and the leg that is opposite of the angle alpha is 1 inch. So therefore, using Pythagorean theorem to find the leg that is adjacent to alpha, that is just equal to 6 inches. So again, if I am interested in using the ratio that is numerically equal to cosine 9.46, isn't it just equal to 50 times adjacent over hypotenuse? For cosine, adjacent is 6. The hypotenuse is 6.083. And I guarantee you that whether you do 50 cosine 9.46 or if you multiply 50 times 6 over 6.083, you will yield the same answer, which is equal to 49.3, and that is in pounds. How about the y component? The y component of 50 is just equal to this component right here. Well, that component is opposite of alpha. I already know the hypotenuse, so therefore I must multiply the hypotenuse by sine of 9.46, and since the y component points down, I have to put a negative sign in front of that term. Or if I'm interested in using the ratio that is numerically equal to sine of 9.46, isn't that just 50 times sine? By definition is opposite over hypotenuse. Opposite is 1 over the hypotenuse is 6.083, and I must put a negative sign in front of that term, and that is equal to negative of 8.22 pounds.